Well, thank you, Alexey, again. Thanks for showing up. Maybe at least wanted to kind of lie to the history. As you know, ClickHouse, phenomenal, fast-growing open source project around the world. Probably 1,000+ enterprises using it, maybe more. And I have now heard so many different use cases people are building on top of ClickHouse and leveraging ClickHouse. And it's kind of obviously a beast on its own in the world when you think about phenomenal introductions of large-scale systems and phenomenal companies like Databricks and Snowflake, and ClickHouse is making smart. So Alexey is always one of the founders. Maybe why don't we start with, how did you think about starting to build a database? I mean, it's a pretty big undertaking. Database has been there around for years, and how did it start to, hey, why don't I kind of start writing from scratch? That's kind of a tough endeavor to take on.
Mm-hmm. Actually, I never wanted to write a database from scratch because it is insane. It is a huge waste of time. It is a huge amount of efforts to make it, and you just cannot make a good database in 1 year. ClickHouse started being implemented in 2009, and I did not anticipate that it will be a full-feature database. That time I did not anticipate that it will be open source. I just tried to make a solution for a very specific problem, making a service to process all the traffic from the internet and analyze it in real time. And I did not want to write code, I did not want to make specialized systems, so I researched what was available. MySQL could not keep up with this task. There were some analytical databases, OLAP databases, like this. Yeah, question?
All the traffic of all the internet.
Almost all visible traffic. So if you have a service like Google Analytics, it processes what the counter, the JavaScript code would catch. It will be not all the internet, not even all the web, but pretty significant part of it. And even if you take around 5%, you will get more than 100 billion records a day. What do you think about putting 100 million records a day into MySQL or Postgres or MongoDB?
It's web scale.
So there were some databases like InfinityDB. It does not exist anymore. InfoBright. It still exists, but almost disappeared. MongoDB, a research database. It did not work for specific use cases. LucidDB also does not exist anymore. Hadoop and Spark, but Spark did not support Spark SQL, at least Hadoop. Not for this kind of tasks, just for batch processing. Vertica, too expensive, cannot be used without bankrupting the company. So I tried to make a prototype of this system, and I figured out that the data structures behind it are not really hard to make. You just have to put attention what the system will do inside. Just to put a little bit more attention to that. And this is how ClickHouse started. So after 7 years, we decided maybe it makes sense to make it open source, and this decision was good.
Yeah, so far it's been phenomenal. So great call on that. I mean, so obviously it started with solving a specific problem. Seems like you looked around the world and didn't find it. Is there maybe a specific trend that ClickHouse is addressing? In your head, every single problem, every single solution solves to a specific problem, but do you think that what ClickHouse is serving to, is it following some large mega trend that you're seeing, obviously from your enterprise customers that's growing as such?
The main trend is that real-time analytics becomes more popular. Until a few years ago, people did not think that it is possible to use systems like for data warehousing, analytical databases as a backend for something interactive, something that is directly queryable by users. But thanks to the white top, it is possible, it is demonstrated, and it makes sense. And the amount of data, the data was already there, but it was just not used, not put into action. Now it is possible, and people start to uncover that maybe we can use this data set and represent it in interactive form. Maybe we can use this data set. Maybe we can update it in real time. Before ClickHouse, analytical databases existed, but it was people tend to think that either you use a transactional database for your application, and you use data warehouse for ad hoc queries from internal users inside your company. But now ClickHouse allows just to open this data, make it visible to more people.
But what's so special about now? Like, what is happening now as you're hearing about the need from enterprises in the internal, that real-time analytics, is more in need and demand, and what's a growing pain and need for that?
Yeah. There are many use cases when you think, if we will save every record, every event, it could be probably just too much data. We cannot do it. But now, you might take everything, whatever. For example, you have traffic lights, you monitor cars passing every crosswalk, and you just measure every car. So record everything and get away with that.
And how should one think about, obviously, we've also seen the evolution of general streaming solutions, obviously Confluent, Audio Confluent Project, companies like Panda, and so on. And what's the convergence of that streaming product and that kind of data coming in for all kind of use, obviously, OTT platforms, Netflix, trading use cases, that convergence with the real-time analytics that ClickHouse solves. How does these two products interact and work together?
Sometimes when you want to process streaming data and analyze it, you use some notions like lambda architecture or pipeline.
Right.
So lambda architecture is when you use different systems for historical data and real-time data. With CAP architecture, do you even remember what is CAP modeling?
I don't.
No, because it doesn't matter. And the point is, you don't have to use different systems for real-time and historical data. It is just unnecessary complexity, because with ClickHouse you can get both low latency for insert, so the data is available instantly after insertion, and low latency analytical queries. But yes, you can use Kafka if you want.
Interesting. Okay. One of the things we hear is that obviously every enterprise has to serve systems for different use cases. OLTP is kind of one, and OLAPs. And there's increasing at least talk about convergence of a single platform for OLTP and OLAPs and so forth. I don't know how much that is possible, or is ClickHouse kind of going in that direction? Is that sort of the longer term vision to be that sort of joint to a DB with that product?
It is actually not easy, and it is difficult to achieve, difficult to implement a system that is good both for OLAP and for LTP. There are some attempts to do it. For example, with change data capture, so continuous replication between two systems. But it means that actually we duplicate data inside two different systems. And it could be possible that this duplication, so different representation of the same data, coexist in the same system. But maybe it could work, but it is not like the dream that many people imagine, that there is some magic that is good for what types of queries. There are some compromises, like what if we will just put all the data in memory? Some research systems say that memory is cheap, put everything in memory, and we will get real-time updates and analytics. And that's okay, but how do you get like 10 petabytes of memory? Yep, yeah, of course.
Some, yes. I mean, obviously there are other open source analytical efforts, right? WebDB, Druid, and so forth. Could you maybe compare and contrast, in your view, how does it be compare and contrast to those things and how they're evolving?
There is a concept of relational overlapping and multi-dimensional overlapping. And with multi-dimensional overlapping, the idea is that to make analytical queries faster, you pre-aggregate data by all of the relevant dimensions. The downside of this approach, it does not allow actually ad hoc queries that don't fit into this structure. And it requires you to do this pre-aggregation that would take more computational resources than just than needed. So you like do all the work in advance, and it is still not enough to serve many queries. And many systems have been created from the perspective of multidimensional overlap. I would not say that Druid is that system, but if you look at the architecture of Druid or Pinot, there are multiple components doing different part of the job. And some of them just related to pre-aggregation. With ClickHouse, you'll find that in many cases, you don't need to pre-aggregate data at all. It is possible with projections with materialized views, but not really necessary. And having just a single component, uniform component across all of your cluster, single binding, is way more simple. If we talk about DuckDB, it is interesting because it is not really a database in this library. And you have to, if you ask people, how do I serve queries from this database, they will say, okay, write a script in Python and introduce your own working your own competencies. That is about introduce everything by your own, right? Some people like, I don't know why.
Right, fair enough. I read somewhere that C++, when you're writing this, is a pretty core choice that I guess you talk about for ClickHouse. Can you talk about the design choices as you were thinking about writing it and scaling this from both language perspective or others?
We should compare C++ with managed program languages, with garbage collection such as Java, .NET, Go, and also compare with more modern languages such as Rust. Okay, so let's compare with Java. Java offers that it is simpler to manage memory. You don't have to worry about biometrics and so on. But the problem is when you want to introduce a specific data structures, when you do it in Java, you have to rely on to make these data structures off heap, because otherwise they will just be inefficient from the amount of memory. There is one example from our practice. So there is an amazing product called Zookeeper, used to make coordination in distributed systems. It works perfectly. It works great for this task. But we implemented Zookeeper with the same protocol, the same wire protocol, the same applications can connect to it and think that it is Zookeeper in C++. It is named ClickHouse Keeper.
Okay.
And the amount of memory usage is lower multiple times. I don't remember exact number, something between like 5 and 10 times. Just because we don't use this managed programming language. Okay, so this is one point. If you compare to something like Rust, you will find a lot of similarities, a lot of good common things in this programming language, such as zero-cost abstractions. If you want to write code that looks simple from the programmer's perspective, and rely on libraries that abstracts this complexity, both C++ and Rust will change. There are some differences. For example, in C++, it is easier to make data structures like self-referential data structures. It gives more freedom, but you have to pay for it with more extensive testing. C++ just requires it. It is almost insane to write in C++ without sanitizing himself fuzzers. And I know C++, I don't know Rust.
That is definitely one criteria. Since we're talking about Java a little bit, maybe it's a relevant point here. Many large enterprises, in fact, say a significant portion of Fortune 500s, also run all their workloads in Spark. So Spark is also a large-scale, very successful open source project, obviously Java-based. So I also hear on the other side, it is good for many things, but also it's very inefficient given it's Java. So how do you, where do you think ClickHouse intersect with Spark data processing, and what kind of workloads enterprises that make design choices of, and it could be leveraging ClickHouse for? All, some, or there are certain kind of things that are good for one versus the others.
By the way, there is a possibility to speed up Spark with ClickHouse. There is a project named Apache Gluten.
Yeah.
And it has ClickHouse-based query engine with Spark compatibility.
Interesting.
And in general, if you compare ClickHouse with Spark, Spark is more for batch processing, experiments, data preparation, experiments on the data. ClickHouse is more for production workload for your application. And you can combine both of them, like make a pipeline for data processing with Spark. Put the result into ClickHouse, sort this data. Sometimes it is not necessary. For example, if the only thing that you use from Spark is Spark SQL, even without custom user-defined functions, try to do it on ClickHouse. Maybe it will be better, simpler.
Okay. Could you share a little bit about the product roadmap? So, obviously, ClickHouse Inc., which is the commercial company around it, you're obviously building a bunch of products around it. So, could you share a little bit about what the roadmap looks like from there on? What are some exciting things coming up? The market makes nice growth.
By the way, as ClickHouse is open source, our roadmap is also publicly available on GitHub. We publish it in January every year, and we commit to make like 50% of the roadmap, maybe 60% of the roadmap. And for this year, the main part was about data types and data structures. We introduced new data types for semi-structured data. So when you have data with arbitrary nested JSON fields, like custom logs, application logs, actually they are mostly uniform. So it's what you can just define the data types. But sometimes this JSON data is just so complex that you don't want to do it. Sometimes you don't know these data types in advance.
Yeah.
So with JSON type, data type, you can store it into inside ClickHouse in a columnar format.
It is.
So it will be a semi-structured data, but the storage will be as efficient as with explicitly defined types. And query processing will be also as efficient if you analyze if you query specific fields from this JSON. So this is one of the main achievements, but we still have a lot of work to do. We introduced it in August this year in version 24.8.
Yeah.
I think currently it is under the experimental flag, so we are collecting feedback from you. I would expect to see feedback about this data type. But I expect in the next few versions, we will promote it to production. And we have a lot of work to do for query processing, especially for query optimizations.
Right. Right. What's your view on sort of data lakes and does ClickHouse support some of these open source formats like Iceberg and so forth, and we're continuing to keep supporting it?
By the way, this is one item for which we have to reprioritize it in our roadmap. So we did not have data lakes planned. At least we did not have a lot planned for this year, but today we see we have to do it. We cannot avoid it. Today, ClickHouse has support for Iceberg, Delta Lake, and Hoodie, so all three data lakes. But this support is quite incomplete. For example, currently we don't have support for data catalogs. So for every table you have to predefine it in ClickHouse. You cannot just say plug in this database. For Iceberg, we still don't have support for schema evaluation. So if you change the schema for your Iceberg table, ClickHouse will require either recreation of this table or just cannot query it. It's quite sad, but we have to implement this feature. There are some performance optimizations and basic features like the ability to process Iceberg tables in a distributed fashion. It is just must-have. It's not hard to implement, so we will do it quite soon.
Okay. I mean, obviously, the world of machine learning AI is exploding. More and more sort of workloads kind of around that. What kind of use cases for AI and ML do you support, or the ClickHouse supports as such today? And are there more product development efforts just come from that kind of community and that kind of use cases?
I see three different use cases. One is what you do with your data before it goes to training your models. It is about data preparation, data profiling, data quality, feature engineering. Like you have a lot of logs about your users, and you want to make a model for anti-fraud. It doesn't have to be AI in the most fashionable sense. It could be a boring machine learning.
Yeah. Yeah. Traditional, okay.
Yeah, but still you have to construct your features. And your features could be related to user history. So they will involve complex aggregations. They possibly will involve data sketches, like approximate counts or quantiles. And to create these features, you use ClickHouse. So this is the first. The second use case is ML ops and AI observability. The main problem with this area is when you have data pipelines for your machine learning, typically they create a lot of artifacts and it becomes a mess. Sometimes models are not reproducible. You cannot repeat your experiments. Sometimes you just cannot find these artifacts. And there are companies using ClickHouse for specifically this use case, like weights and biases, line chain.
Yeah.
They try to organize these processes. They do ClickHouse. And you might say, the first two use cases don't make, not actually run AI in the process. They are around AI. ClickHouse is used by AI companies, but ClickHouse is just a database. Right? It's a pretty solid production, great database that everyone likes to use. There is also interesting third use case, semantic search.
Right.
Not only search, also semantic analytics. When you have multimodal data or either just text, image data, and you want to use it in your database, and instead of storing this text images as is, you just convert them to vector embeddings. And you can do a lot of interesting applications using these vector embeddings. For example, you can find some subset of objects, subset of texts in ClickHouse using these vectors and vector distances. Copy them into context and provide it to an LLM. And this LLM will generate some answers, and you can provide direct references for these answers. So you will also explain the result that LLM produces. It is named retrieval augmented generation.
Right. Rather than the three.
Yeah. And it is not only about search, we can analyze a large subset of this data. Maybe we can say it is like analytics augmented generation. I don't know if this term exists, quite different. I have about it. We can do that.
All right. Well, changing gears a little bit. I mean, a lot of audience here. Hopefully, many of them are contributing to open source and so forth. You know, from your own journey, maybe stitching together some of your background and professional and academic and so forth. What does it take to be a good open source developer? And then maybe also talk about, you know, how should one thinking about, you know, picking between open source versus closed source choices, just both of them, I guess.
Yeah. Open source makes you open to different usage scenarios of a product that you did not anticipate before. Initially, I thought maybe ClickHouse is quite a decent database for analyzing web logs, but now it is used for medical applications. It is used for astronomy. I did not know about this use case, it was not open source. Also, I would say that open source improves the quality of the product. It's quite controversial, but it would improve user experience. Not always. There are a lot of sketchy open source products, but it improves user experience if you actually pay a lot of attention to user feedback, contributors, and it requires dedication. The problem, it requires dedication in a long distance. So it is not like something you make open source, you spend like 1 month and go away, and it will sustain by itself. I see that working on open source product requires dedication for a whole team for a long time. You have to constantly pay attention to it. It's a price you have to pay.
Fair enough. What's the advice for folks here? How to engage with ClickHouse, both open source community and how could they, contribute and also the second way to pick it up and learn it?
We have open source code, but also open source processes around the code. There is documentation how to start working with ClickHouse, how to build ClickHouse. There is a list of feature requests and issues for first-time contributors. Even if you don't know C++, you can submit to our documentation. And by the way, inside ClickHouse, on every production ClickHouse installation, you will find a table named system.contributors. And if you are a ClickHouse contributor, if you have ever contributed just a single commit, you will be in that table. You can brag about it. Like you go to the office, this office, jump trading approach to CEO or jump trading. And he will ask you who you are, what are you doing here? And he will say, my name is on all your production settings.